Hello everyone, we are Team Jumo with Ivan, and the team members are Yureni, Montserrat, and Ivan. We are going to present our project. The topics that we chose for our partial project are the four main interactions of energy, the different types of energy, and the daily lives examples of these types of energy. So, to begin with, our teammate Yureni is going to explain about the four main interactions of energy.
Four interactions of energy. We will explain this topic by using reports for each one of these: strong nuclear, weak nuclear, gravity, and electromagnetic force. Strong nuclear. This can act in two ways. The first one is when it keeps protons in the nucleus despite the repulsion force. This is possible because of gluons, which has the ability of change the color or flavor of quarks. All this in order to keep the overall charge of the baryon neutral. As we can see in the sketch, red light, blue light, and green light equals white light. The second one is when a strong force connects quarks to form protons and neutrons, because of the interaction between gluons and quarks in the proton providing excess color charge that overwhelms the electromagnetic repulsion by protons. Weak nuclear. Particles interact through weak force by exchanging force carrier particles known as W and Z. These ones have masses about 100 times the mass of a proton. This is the reason why weak force is defined with extremely short range nature. An example is beta decay, where a neutron disappears and it is replaced by a proton. It is also proven that a down quark disappears and an up quark is produced. Electromagnetic force holds electrons in their orbits around the nucleus. These electrons interact with other electrons to form bonds among elements, producing molecules and eventually visible matter. Without these bonds, matter will cease to exist beyond atomic level. When electrons are jumping energy levels, they provide us visible light. Gravity. This is the force we are more familiar with because attracts all matter on Earth. It's also responsible for creating sun, moon, planets, stars, and celestial bodies. Without it, they will be nothing but gas. Now that I have explained all force interactions, here's a little review. Strong force keeps protons in the nucleus and connects quarks to form protons and neutrons. It's also the most powerful force with one of the shortest interaction distances. Weak force. It is involved in a beta decay and other radioactive process. All particles experience this, and it's effective at short distances. If weak force does not exist, many types of matter will become much more stable. Gravity attracts all matter, but it's too weak to have significant effects at subatomic scales. Electromagnetic force is responsible for electromagnetism and most of the interactions we see in our environment.
Despite the next information might sound a little bit obvious, it's important for the listener to understand that some interactions are more powerful than others. So in order to arrange them from strongest to weakest, here's the list. The more powerful or the strongest is the strong nuclear with a value of 1. Then the second strongest is the electromagnetism with a value of 1 over 137. The third one is weak nuclear with a value of 1 times 10 at the negative 9th power, and the weakest of all is gravity with a value of 1 times 10 at the negative 35th power. Okay, the next topic we are going to talk about is different types of energy, where we are going to create a list or a countdown where we will try to explain how they work and what they can be used for. Specifically, we are going to talk about the 5 most important energies that we will be using in the future according to scientists. The first energy we are going to talk about is solar energy, which consists in absorbing and using the light and the heat of the sun in order to transform them into electrical energy. According to the United Nations Development Program, the potential energy that can achieve the solar energy is 49,837 exajoules, which is several times larger than the total energy world consumption since 2012. Maybe this is why Nikola Tesla once said, If we use our fuel to get our power, we are living on our capital and exhausting it rapidly. This method is barbarous and wantonly wasteful, and we will have to be stopped in the interest of coming generations. The heat of the sun rays represents an immense amount of energy vastly in excess of water power. The sun's energy controlled to create lakes and rivers for motive purposes and transformation of arid deserts into fertile land. This was a phrase that Nikola Tesla said in an interview that was made to him on September 9th in 1915. The second energy we are going to talk about is wind power or aeolic energy. This consists in the use of the airflow through wind turbines to mechanically power some generators to produce and transform this aeolic energy in electric energy. Because of the fossil fuels, alternative energies, and also alternative ways to produce electrical energy are getting very popular in developed countries. In the case of the aeolic energy, it's very popular in Europe in some places. For example, in Denmark, approximately 40% of its energy, of its electrical energy, it's produced by aeolic energy. So despite this is a renewable energy and an alternative way to produce electrical energy, this type of energy, I mean aeolic energy, produces several rates of energy, which some of them can be pretty low. So this energy can be used among other energies like normal electrical energy in order to be a reliable source of energy, because the aeolic energy by itself can be really disappointing sometimes because it doesn't depend on us. The third energy we are going to talk about, it's called nuclear power or nuclear energy, and this is the use of nuclear reactions that release nuclear energy to generate heat, which most frequently it is used in a steam turbine, but it can also be produced in a nuclear plant. But what is a nuclear reaction? In nuclear physics and nuclear chemistry, a nuclear reaction is semantically considered to be the process in which two nucleus or else nucleus of an atom and a subatomic particle such as a proton, a neutron, a photon, or an energy electron from outside the atom collide to produce one or more nuclides that are different from the first one. But this process in which these atoms react with each other freeze or release an highly amount of energy, which can be and it is being used to produce electrical energy because of this reaction release of highly amount of energy. The fourth type of energy we are going to talk about is electrical energy. This energy is newly derived from electrical potential energy or kinetic energy, but it is absorbed or delivered by an electrical circuit. Electrical generation is a process of generating electrical energy from other forms of energy, like eolical or nuclear or some others. The fundamental principles of electricity generation were discovered during the 1820s by the British scientist Michael Faraday, and we still use the same methodology to do these things today. And the last energy we are going to talk about is hydraulic energy. This energy consists, or its definition is what is produced by the water which is stored in reservoirs, lakes at high altitude, so that they may have gravitational potential energy. If at given moment it falls to a lower level, this energy is transformed into kinetic energy and afterwards into an electrical energy by the hydroelectric plant. But energy is not just a way to produce more types of energy like electrical energy. That's why our teammate Montserrat is going to tell us about some daily life uses about energy. Not these types of energy, but every kind of energy that requires an amount of work.
Hi, welcome to this part of our podcast. My name is Monse, and today we're going to be with Christina, our special guest that is interested in physics and study what does energy acts. She's going to tell us about everyday examples of different types of energy manifestation. Thanks for being with us, Christina. How are you?
Hi, fine, thank you. I'm so excited for being here.
It's a pleasure for us. So, what can you tell us about energy manifestation? Hi, welcome to this part of our podcast. My name is Monse, and today we're going to be with Christina, our special guest that is interested in physics and study what does energy acts. She's going to tell us about everyday examples of different types of energy manifestation. Thanks for being with us, Christina. How are you?
Hi, fine, thank you. I'm so excited for being here.
It's a pleasure for us. So, what can you tell us about energy manifestation?
We have internal energy, heat or thermal energy, chemical energy, electrical energy, nuclear energy, among others.
Wow! But how can we perceive energy in our everyday life?
There are so many examples. Life moves because of energy. Every time you see a person moving, or even you, it's because of energy. The computer that you use and the cell phone you're using to record needs energy. Even nature gives us the resources to create energy, like the aeolic one that works with the wind, and the hydroelectric energy that uses the force of water, or the energy based on the sea waves. There is energy in everything around us.
Yes, you're right. We can't exist without energy. Thanks for the information and taking some minutes of your time to be with us.
You're welcome. It was a pleasure for me.
That's everything for this section. Thank you.
Goodbye.
Okay, that was our podcast for this partial project. I hope you like it and that you learn many new things. We are Team Yumo and we thank you for listening.